What I'll do on this slide is review the equations that we went through in a previous lesson, and then we'll use some of those equations later on in this lesson and in the next two. For a force moving through a distance, work is found by these equations. The input work is the effort force times the effort distance. The output work is equal to the resistance force times the resistance distance. The equations for ideal and actual mechanical advantages. The ideal mechanical advantage is the effort distance divided by the resistance distance. The actual mechanical advantage is the resistance force divided by the effort force. For an inclined plane, the ideal mechanical advantage is equal to the length of the plane divided by its height. The efficiency can be found with any one of these relations: the output work divided by the input work, the actual divided by the ideal mechanical advantage, or FRDR divided by FEDE. And then typically an efficiency is reported as a percentage, so you would want to multiply by 100. In general, DE and DR could refer either to lever arms measured from the fulcrum or distances forces move. For work, however, they refer only to distances forces move. We have a first-class lever. Notice that in a first-class lever, the fulcrum is in the middle, and all lever arms are measured relative to that fulcrum. This first-class lever is 2.13 meters long. The effort force is 320 newtons downward and is 1.60 meters from the fulcrum. An 85 kilogram mass is to be lifted, and it is 0.53 meters from the fulcrum. Find the ideal, actual mechanical advantage, and the efficiency. There's our picture of the information that we have. So let's go to our equation toolbox. The ideal mechanical advantage is dE divided by dR. That's 1.60 divided by 0.53, or 3.0. Mechanical advantages have no units, they're simply numbers. Our equation toolbox says that the actual mechanical advantage is FR over FE. Well, FE, the denominator, will be 320. FR is going to be the weight of that mass. 85 times 9.81 meters per second squared divided by 320 newtons, 2.6. This should not surprise us that the actual is less than the ideal mechanical advantage. How about efficiency? If we look at our equation toolbox, there's one equation for efficiency, and that looks like a pretty good choice because we know the actual and ideal mechanical advantages. We're going to convert that into a percentage, 87%.